the first virtual meetup. Oh, I'm sorry. I forgot our subtitle, NYC DevOps, the DevOps meetup that puts New York City first. This is a very special meetup because it's our first virtual meetup. And you know, DevOps is about change and trying new things, right? So we got a lot of new stuff. We're playing around with some video conferencing stuff. The social aspect is a little different. We're growing and learning and trying different things. Normally at this time, a dozen pizzas and a few cases of beer have arrived. And I gotta tell you, I'm halfway through one of those pizzas, but I do not think I could eat all 12. So the beer, I think I got that covered. Some things have not changed. It's our goal to have great speakers, and we have some we have a great speaker for you tonight, and also coming up in October, Nathan Harvey from Google is going to be doing an intro to SRE. In November, John Allspaw, kind of a local celebrity, will be speaking. We're still working on the exact topic, but knowing John Allspaw, it's definitely be something related to incident response and chaos engineering. He's doing some amazing work with that. December, we usually don't have a meeting because the holidays. We're thinking about doing maybe some kind of social meetup. We have the Zoom, feature with the breakout rooms. So we're thinking like maybe we could work something out like that. If you have some thoughts on that, please maybe mention in chat to the hosts. Oh, and speaking of the hosts, I should I should introduce myself and the other hosts. Or maybe we should introduce ourselves. My name's Tom Limoncelli. I work at stackoverflow.com. You may have heard of that, or if you have children, we do their computer science homework for them. Russ, why don't you introduce yourself next?
Yeah, I'm Russ Kaler. I'm at Compass. Yeah, I've been part of the NYC DevOps meetup for a year and a half now.
Cool. And Adarsh will get a bigger introduction in a second, but why don't you say hello?
Hello, everyone.
Cool.
Thanks for joining.
So that's December. Oh, and then in 2021, we want to make it even better. So, DevOps is about being data-driven. So look out for a survey about what we should do in 2021. We really need your feedback. So look for that in the mail in the next week or two. We always begin the meeting by having a little moment for community announcements. If you have a conference, meetup, if you're looking for a job, this is your time. So I have no idea how I'm going to organize this. So why don't you just unmute and start talking and we'll see how that works.
Hey, Tom, this is Alec. So I actually attended one of your meetups probably in 2013 at this point, New York City. And 2016, I started a group in the AI space. So we've had 36 events so far, had last one on voice. We also done AutoML, NLP. So I'll just post a link in the group. And if anyone's interested, happy to have more members, and anyone who has any idea of happy to have that as well. Thank you.
That's great. Any other announcements? I will mention that the DevOps Enterprise Summit, which is normally in Vegas this month or next month, will be virtual, and it's really the best conference for your bosses, your executives, your CEO, who's like, what the hell is this DevOps stuff and what can it do for me? Highly recommended. Gene Kim. It's basically Gene Kim's conference, and Gene Kim he's the guy that led the Phoenix Project book, and he brings all of his best friends and amazing speakers together. It'll be virtual, so it's easy to attend. Any other conferences? I know there's. SRE Con.
All Day DevOps is. Yeah. All Day DevOps will be in November. I don't know exact date. I think it's the first or the second week.
Okay. Right.
That's the online.
All Day DevOps is great. It's 24 hours of DevOps related talks, and it's free. It's they do it all with sponsorship money, and a lot of great speakers, and you can just tune in for, you know, whatever daylight hours are interesting for you. Also, SRECon went virtual, so I think December 10th that week. It's a 3-day conference. Maybe we should email out some of these. Any last announcements? Okay, hearing none, it's time to introduce our speaker. Adarsh Shah is an independent consultant and DevOps coach. He's also an organizer for the DevOps Days New York City conference and this very meetup. I'm particularly excited about this talk for 2 reasons. One is that ML is something that I know I'm going to be doing a lot more in 2021, so I'm happy to get a little preview of what I need to know. And I'm also excited because the fact that he's giving this talk means that the AI-powered robots haven't taken over and are giving the talks themselves. So with that, take it away, Adarsh.
Great. Thanks, Tom, for the introduction, and thanks everyone else for joining. Yeah, so today, as Tom mentioned, I'm going to talk about continuous delivery for machine learning. It's basically about how to deploy ML systems to production safely and quickly in a sustainable way. So this talk is based on my experience working with continuous delivery over the years with traditional software. And then for the last couple of years, I've been working with machine learning and kind of applying those principles and practices that worked for traditional software to ML systems. And then there are certain unique challenges that machine learning has that we will go through, and then we'll see how continuous delivery helps solving those challenges as well. Okay, so let's see, my clicker is off. Okay. All right. Okay, perfect. But let me also quickly introduce in a different way. But yeah, I mean, all the stuff like independent consultant, and you can find more info about me on my website. But I love cricket, as you can see in the picture in the center. That's me batting. And then I love whiskey. So feel free to stop me for any time for any questions if you have, and we'll have some time towards the end. But I can't guarantee if I'll be able to answer that correctly unless it's about whiskey or cricket. Okay, so ML and DevOps maybe, but definitely whiskey and cricket. So if you want to geek out about any of these things, even afterwards, yeah, let me know. All right, cool. So one of the known truths of the ML world is that it takes a lot longer to deploy ML models to production than to develop it. So according to the paper, Hidden Technical Debt in ML Systems, only a small fraction of real-world ML systems are composed of the ML code. As you can see in that small, tiny ML code box, everything else, right, surrounding infrastructure is really vast and complex, right? So you have infrastructure requirements that are special for ML. You have various feature extraction, data collection, configuration, monitoring, all of that surrounds the ML code is massive and complex. Quickly, for those who don't know, I'm going to go through the difference between traditional software and machine learning. So as you can see on the left, in traditional software, you write the program, you provide the data, it goes through computation, and then you get the results. Next time you want to change something, you change the program, or if there is a change in the data, you change the data, and then it again does the compute, and you get the results. In case of machine learning, it's a little different. So on the left, you actually provide what's the desired results that you have, right? So you have that desired result, you provide the training data set, right? Which is basically helps in training the model. And then you pick an architecture, which then goes through a training process that generates a model. That model is basically fed into the program. That program is your application data that gets deployed to production. It might be an API. You have some other kind of web application that uses the model. And then that program, which includes the model, and it starts doing predictions in production with the live data, right? So this is when you look at that right side, which kind of then looks like more traditional software development. But how do you come to the model and how that model gets used to do predictions is different. And then that gives you the results, right? So the right side kind of seems similar. But one thing I will say is, even though fundamentally machine learning is different, most of the principles and practices of software development can be applied to machine learning. But there are certain unique challenges with machine learning as well that we'll look at in a bit. So what is a typical machine learning workflow? There are usually three various components, three parts to it. First one is data management. There is data acquisition and preparation. Data is critical to machine learning. The quality of data determines the quality of the model that gets trained. And so that part is critical. And then the next phase is experimentation. This phase, data scientists spend a lot of time trying out different model architectures, developing the model, training the model with different version of data sets, and then seeing if they can meet the accuracy that they want to achieve. So there is an accuracy evaluation step there. If they don't achieve that accuracy, they go in a loop, right? So they try different things until they actually achieve that accuracy. Once they achieve that accuracy, the model gets deployed along with the application to production, and it starts doing live prediction with live data. And then you have your typical monitoring and alerting, but in case of machine learning, you also need to look for things like data drift, whether the accuracy for your model starts going down below the threshold that you have. And if that happens, you need to do a fix for your data drift or retrain the model to improve the accuracy. So this is kind of a typical machine learning workflow. So let's now talk about the challenges that are unique to machine learning. So first phase, we talked about data management, and the first thing is large data sets. To train models, it usually takes hundreds of gigabytes or even larger, right? Sometimes terabytes of data to train the model right. And for that, it brings certain challenges. You can't just do things manually. You have to have proper checks and balances to make sure that you can automate and repeat that process. There's also data location. In certain cases, if that data has sensitive information or compliance, if the industry that your company is in has compliance requirements, you can't have that data leave the premises. So in certain cases, having also moving that large data set that we talked about across various locations is costly and it's time consuming. So thinking about how to actually minimize movement of that data or optimizing it is important. And then the data quality. So as I mentioned earlier, the quality of the model heavily depends on the quality of the data that you use. And we look at some of the things that can help verify that the quality stays high. And then the next one is a tracking data set, right? So when you are doing experiments, you want to try different versions of data, different sources of data, and see what works well and what gives you better performing models. So tracking that, versioning them is a really good way to see and go back to a previous version if needed. When we talk about data, right, a lot of data is sensitive, right? And then also compliant. You have to be compliant to certain compliance requirements like PII if you have personal information that you store, or if you are in the healthcare sector, look at HIPAA, or in Europe, GDPR, right? So all those compliance requirements. So whenever you are taking data in from any source, you need to make sure that you don't have any data leaks, or you are complying with the requirements that you have to. And then comes the experimentation phase. This phase, like I said, a lot of research and experimentation happens. The data scientists spend time trying different things, seeing what works and what doesn't, which actually is different than traditional software development, because yes, there is research, a little bit of research and experimentation in traditional software, but here the workflow is different. Data scientists are not focused on the code quality. What they are focused on is what are the various components that work. They are not focused on deploying to production. They are focused on their research part, and which brings the challenge where a lot of times when you try to deploy stuff to production, the code is not of production quality. Next one is training time and troubleshooting. So usually training takes hours or sometimes days. I had one of the use cases that I was working with these data scientists, it took like 3 to 4 days to actually train the model. So if something goes wrong, you should provide the right tool sets to troubleshoot and even restart or continue the training after you fix the issue. And one of the examples that I would give is like a full build of Tesla Autopilot. The neural networks takes 70,000 GPU hours, right? So it doesn't mean it takes that many hours, but that much GPU hours. So if you have more GPUs, you can reduce that hours, but to train that neural network, it actually takes that much time. This is as per their website, by the way. And then you have to do the model accuracy evaluation. If you automate that, you can easily benchmark different tests, track them, and then compare how that performance. Then again, tracking experiments is a big part of this. And then the infrastructure requirements. So I mentioned GPU earlier. A lot of machine learning models require special hardware and infrastructure like high density cores or GPUs, because they are a lot intensive in compute, like especially if you have images that you process, you require GPU. And with that comes complications like GPU is expensive. If you have to buy the hardware, that's expensive. Or if you use a cloud provider, you have to be cognizant that you don't keep that GPU instance running all the time, otherwise you'll incur costs. The third phase is the production deployment, right? So one of the differences in how to do prediction in production is an offline and an online version, right? So offline is basically you're doing batch processing and then providing information, so more like an offline processing and predicting. And then you have the online, which is more real time. So when you think about deploying ML systems, providing support for what the needs are, right? Either offline, online, or both is pretty important. And then, like I said, monitoring and alerting. So having monitoring and alerting capability for your models, monitoring how they are performing in production. If the performance degrades or if there is a data drift, having appropriate alerting is really important. And I added this based on my experience, and I'm going to explain what this is. This is not one of the phases, but I wanted to add this challenge because so I've been working with a lot of Raspberry Pi-like devices like Jetson Nanos, which have GPU, so you can run machine learning workloads in there. And believe me, the libraries that are available, so most of the ML stuff is Python, right? And Python has dependency issues, but especially these dependencies are massive, large. So you work with some of these libraries from NVIDIA, really like the sizes are large, support for things like Docker, right? Because those Docker images become huge, are less, and that creates challenges. And especially if you're working with ARM architecture, which is what Jetson Nano and some of the other hardware that's available for machine learning is. Okay, so let's quickly go through continuous delivery, and then we can look at how to apply that to machine learning. So continuous delivery is the ability to get changes of all types, including new features, configuration changes, bug fixes, and experiments into production, right? So basically into the hands of your users safely and quickly in a sustainable way. As you can see, that's in bold. Safely and quickly is important, and getting it in a sustainable way to your end users. By the way, this definition is from the book Continuous Delivery that was written 10 years ago, still relevant, right? I still refer Jez Humble's blog or go back to the book a lot of times. So read that book if you haven't, it's still relevant. So that's the definition. Quickly, difference between batch processing and a single piece flow, which is what actually continuous delivery is. So in batch processing, you do things in batches and you find defects later because you integrate things later on, right? So you do things in batches like inspection towards the end, and that causes delays in finding the root cause and causes a lot of waste. Versus single piece flow, you take one thing at a time and take it all the way and get the finished product. So you can find any issues sooner rather than later. So the batch processing, actually, Henry Ford, the Ford car company, he in 1930s started doing this mass production and batch processing. And that gave Ford a lot of advantage because yes, batch processing helps with certain things. You're doing the same thing again and again in bigger batches, but then they started having issues finding when they were integrating various parts of the car. They said, okay, the wheel had some issues and the whole batch had issues, right? So you got to go back and kind of fix those issues, and that was costly. On the right side, Toyota started doing single piece flow, and Taiichi Ono, the person at Toyota who actually started, and I'm going to talk about Toyota production systems later, but they started doing single piece flow. Take one thing at a time, get it to finish, right? A lot of things like Kanban and other things come from Toyota. So just wanted to go through the difference here. What is continuous integration? To summarize, it's basically where you start. If you're not doing continuous delivery, this is the bare minimum. That's the first step you need to take. It is basically where team members integrate their work frequently, potentially daily or even multiple times a day, right? And when that happens, integration happens, you verify that with an automated build, right? Including automated tests, and detect any integration errors as quickly as possible, right? Same as the single piece flow, doing things in a smaller chunk, making smaller commits, and then finding issues faster. And then here, I'm not going to talk about continuous deployment a lot here today, or in fact, not much. But just the difference between continuous delivery and deployment, I know a lot of people get confused. In delivery, you have that last manual step, as you can see on the right, where before you deploy to production, you hit a button or approve or something. In continuous deployment, you do auto deploys directly to production if all the tests pass. And a lot of high-performing teams do continuous deployment, but it takes a lot of maturity to go there. Okay, so what are the principles of continuous delivery, right? So first one, build quality in, right? So according to Edward Deming, one of the key figures in the lean movement, right? So he talks about this 14 principles for management. And the second principle there is cease dependence of inspection to achieve quality. Eliminate the need for inspection on a mass basis. by building quality into the product in the first place, right? So don't do inspection, this massive inspection towards the end, but build that in your product, right? So we talk about CI and we talk about continuous delivery. The idea is getting that faster feedback and building those tests and quality in that so that you can find those issues faster. And then work in small batches. I explained the difference between batch processing and getting a single piece flow. That's what this talks about. So faster feedback. So computers perform repetitive tasks, right? They're good at doing repetitive things, but people solve problems. So there is a word for this called jidoka in Toyota production system. It's a Japanese word which says automation with a human touch, right? Automation cannot solve everything. You need the human touch. Humans are good at solving problems. They are key. So keeping that in mind is important. And then Kaizen. Kaizen is basically continuous improvement, right? So keep on looking at improving things in your flow from start to finish. And then everyone is responsible. And how many times you have heard that this is somebody else's problem? A lot of organizations, a lot of teams, I hear this so many times when I work with clients. It's like, not my problem. I'm going to pass. This is the other team's problem. It is a very difficult challenge, and it's a very difficult thing to solve. But doing things like aligning incentives, right, of different teams with the organization incentives help with the mindset. But it is an important part of continuous delivery. I'm not going to go through this, but if you're interested more in Toyota production systems, like I said, a lot of learnings in software and best practices come from that. So I would highly recommend that. Okay, so now let's look at how do we apply those continuous delivery principles to machine learning, right? So one of the first phase that we talked about was data management, right? So data being critical. And one of the things that you can do is have an automated data pipeline, right? So as you can see, the first step is data acquisition. So basically, you acquire data from various sources, right? So I had to work with S3 or some public data sets that are available. And then, if customer gives you data in a different storage, you kind of have to acquire that, right? So doing authentication and other things that are available, that are needed. And then doing a validation to make sure that the data format is correct. If there are any issues with, let's say, one example I had is we were getting images from different sources, and then from one source, the image caption was in a different language. So we had to actually do translation and translate those caption because that caption data was important for training. So having that validation is important. And then based on the validation, if you have to do some normalization of the data, transformation of the data, or feature extraction, you don't do those things in an automated way. And then basically apply that change across various sources, right? So having various adapters for your various data sources helps you to process data from various sources and then validate and prepare. Next one is testing. Two important things, bias and fairness, right? This is so important. I cannot stress enough. And there are studies done, and I have a link towards the end in my references by folks who say there's so much bias in the data itself, right? Race, gender, religion bias, so that the model that gets generated is biased, right? So there are stories out there where credit card companies being biased towards, one community versus the other. So having this testing, so you're not introducing bias in your model by the way of data is critical. And then security and compliance. There are tools out there to make sure that your data is secure and compliant, right? So you can write compliance as code. You can have security testing tools available that help you in testing the data in that state at this stage. And then when you get the training data set, you version them, version the data so that you can go back to it, try that in your training process. Now, the challenges that I talked about, right? Large data set, high quality data, security compliance, data tracking, and basically location, parts of it, like having a data pipeline helps you resolve those issues. Now, one thing that's not mentioned here in the diagram is that this enables collaboration. If you have a special security or a compliance team, they will get involved in this stage, right? So even though you have automation, the rules for compliance, the rules for security are set by those teams. So this enables collaboration between security compliance teams, your data engineers, if you have data engineers or data scientists in general who are working on this phase, right? So a people part of it also comes here. Okay, so next one is your training code, right? So you need to write your training code, and that code needs should go through a continuous integration step. Even though this is the code that is not going to be deployed in production, I have seen issue creep up just because your code quality for training is so low, and the maintenance becomes a nightmare. So on the left, again, when you merge to your main branch, after doing your experiments with your Jupyter notebook in a dev environment kind of setting, it should go through a CI process, right? CI being you run your static analysis, your linting, your unit test, and things like that. And then it should have some kind of artifact. I have Docker mentioned here. You don't have to use Docker. It can be a zip file. Version the zip file and put it in a place where you can grab it when you need it. And then comes actual training process, right? So we talked about the data pipeline that gives you the training data set. Then we talked about the continuous integration for your training code. That data scientists then work with Jupyter Notebook, kind of trigger the training process in most cases. In some cases, it can be automated. And then it goes through this training process where you have a training environment, which I would highly recommend to automate provisioning and deprovisioning, right? Especially for hardware that is expensive, right? GPU and other expensive hardware in the cloud or on premises. In on premises, you already bought the hardware, but you want to free up the hardware for others. So having that automated provisioning and deprovisioning of an environment is a critical step. And then adding accuracy evaluation, right? So once the training is done, can you actually compare and see how it ran with the previous run and whether you're reaching your goals, your accuracy levels that you want to achieve. And then again, testing here for fairness and bias, right? So data is one thing, but also you can have your biases based on the code for training or the architecture that you're using for your training. And then for training process, also have the monitoring and alerting, right? So if you have a 4-day training process running and then midway something happens, you should be alerted because again, these data scientists used to start their training, go do other stuff, and then let's say something fails, while it happens, they are not constantly looking at that, right? So alerting them and then providing appropriate logs so that they can troubleshoot if needed. And at the end of the training process is where you get the model, right? So let's say you achieve the accuracy that you want, you have your model, you version that, and that's kind of available for deployment to production. So we talked about the training code. Now let's talk about the application code. Application code is basically the application that gets deployed to production, right? It will consume the model, and we'll see how. But as you can see in the left, there is that model that feeds into the application code, and have a CI here as well, right? So have your static analysis, unit testing, security scans, right? Especially that this code is going to be deployed in production, right? So like in your traditional software, have a CI that gives you a build artifact that potentially spin up an ephemeral environment, a temporary environment where you can deploy that and run your integration tests and then tag it, test it, and then, kind of available for production deployment. So if we bring all this together, right? So we have data management, experimentation, and production deployment as 3 phases. On the left, as you can see, again, data pipeline that gives you the training data set. The next component is your training code. Do a CI there so that you can find any issues with your training code as soon as possible. That then all feeds into, along with the configuration, into the training process. The training process runs that gives you the model. That model then feeds into the CI of your application code. Now, by the way, there are, in some cases, you pull models while you run in production, but you lose some of the aspects of, build once and run everywhere. But you can also do that. But I would recommend packaging that along with your application code. And then you deploy that to production, run some smoke tests, right? Have your monitoring and alerting for your model performance there, and alert your developers or data scientists who can then act on it if the performance goes down. Now, I haven't talked about a lot of typical traditional software practices, right? Like monitoring and alerting, not just for model, but for your infrastructure and other things also matter, right? So all those still apply here. So that was all well and good, right? Like you automate your data pipelines, you enable your CI and have CD and stuff like that. But some of the roles that are with machine learning are a little different, right? So I'm going to talk a little bit about cultural aspects of it, right? So you have a researcher, who builds algorithms and research new techniques, ML engineer, right? Not too much with algorithms, but they kind of use it and build stuff. A data engineer, and then ML ops, I call it, but basically, or people call it, but they are like DevOps people who are working with ML stuff. And then these are the various roles which come into picture. The reason I mentioned that because the researcher role is different here than traditional software. Data engineer role is a little different than traditional software. And that brings unique challenges, right? So certain team structure considerations you need to look at, like cross-functional still works here, right? But it's challenging because I've had a lot of pushback where data scientists who are more research focused working with other folks in the team. But this still, if you can do a cross-functional team, it enables collaboration, work towards a product is the best scenario. You can have a separate data science team, which is what actually I had at the place, the client I was working with, but we kind of collaborated more frequently. We used all the, agile and practices to enable collaboration, right? The incentives for them with other teams were kind of aligned. And then also having a platform engineering team, but this is more like on ML side. There's a whole different talk I have. I don't know if I have the link towards the end, but if you're interested on platform engineering teams in general, that talks about building a platform as a product internally, and then kind of using, but this is more ML focus. These are the various considerations, not that there are no other team structures that work here, but these are the ones that I've seen commonly. And again, the big part, culture is a big part of this. I know a lot of focus here was, building this data pipeline and automation, but having and collaborating and making sure that different teams talk to each other and they have aligned incentives is a critical part of this whole process. I'm not going to go through, I know I already am past the time, so I'm going to skip through this, but there are various platforms available. These are not managed platforms, right? MLflow, Kubeflow, and Airflow. They all have their advantages and stuff, but Kubeflow is the one that I've used most, which is on top of Kubernetes and enables you to do a lot of cloud native stuff. And then these are the managed ones, right? Azure Machine Learning, GCP has its own, and then Amazon SageMaker is another one that's available. Again, this Kubeflow enables you to do a bunch of things. I'm not going to go through that. If you're interested, I'll be sharing the slides so you can take a look or ask me questions. And these are some references that I would recommend you all to kind of look at, right? That helps. The last one that talks about large image data sets, and it's how it's two folks like Abiba Bahrain and Vinay Prabhu, two folks who did this research around ethics and basically bias and on the data sets, and it's really interesting. It's a paper that if you are interested. And then last one is book recommendations if you're interested in learning more about some of these things. And that's the talk. Thanks for listening. And if you have any questions, let me know.
All right. Thank you, Adarsh. Do we want to take some questions?
Yep.
Yeah. So Adarsh, I have a question. What's the difference between a data engineer and a machine learning engineer? And I think Viraj also pretty much said the same thing. Can you please take a simple example and assign tasks on what each of them does? Because I see a lot of job requisitions and a lot of these words where ML engineer and data engineer are used interchangeably. So what is the difference?
Yeah, so data engineers are focused on just the data side of things. So especially when you start off, let's say you have a small data set and stuff like that. People just, like you have this catch-all world of data scientists, right? That does everything. But data engineers are only focused on data, right? So building data pipelines, building automation and other logic to, do transformation to, any kind of feature extraction and those things. ML engineer on the other side is basically, so I'm going to explain ML researcher a bit. So researcher is basically, let's say, none of the machine learning models out there, right? So the architectures out there or the algorithms out there work for you, then you need a researcher who's researching on something brand new, right? Something that is not out there. ML engineer on the other side uses the algorithms. They don't build the algorithm, right? So they use it and then they do things like, the phase where they train the model and then deploy the stuff. But data engineer only focused on data heavily, especially for organizations as they grow and they have a lot of different data sources and stuff. They focus there, and then ML engineer more on, okay, taking that data that's available to them, taking the algorithm that either is publicly available or your researcher provides you, and kind of taking that to production. Does that make sense?
Yes, makes absolute sense. Thank you so much. This really helps.
Okay, no problem.
We have a question in the chat room from Alec. Alec, do you want to?
Oh yeah, let me. I don't have it up, but.
Oh, okay.
For sure. Yeah.
He says, at what point do you switch from ML projects to? I'm sorry. At what point do you switch from ML projects to prove out the ideas and ROI to using CI/CD for ML type, whole platform? What questions would you ask to know it's the right time?
Right, right. Yeah, I mean, and this is the most challenging thing, right? So it's a great question because, again, like researchers are doing so many different things, right? They're trying so many things, and it doesn't make sense to automate everything, right? Because then you get into this weird state. Uh, so a lot of MVP, like building an MVP kind of logic, right? So for our case, what used to happen is researchers they research on their own, and then they have their own environment, right? So they are doing a lot of things manually initially. When they get confidence in the model in a way where they are like, okay, now this is the time where, we can use these in a more production way, or deploy it to like a demo environment, right? So these data scientists used to create a lot of demos for clients, and they used to show stuff. So we used to kind of take it there where it's like, okay, now is the time where they want to do the demo and show that new thing. Now, if you're changing an existing model or modifying stuff, that still should go through the CI, right? Like, and have the CD aspects, CI/CD aspects. So for totally brand new stuff, which has never been automated and never been, we used to at least have this, right? And again, I know this doesn't apply for everyone, right? Everyone has different use case, but for us, it was like, this is good enough. Should we start demoing, maybe even internally, actually, demoing it internally and see if we want to iterate over it and get it better. I don't know if that helps, but that was one use case that we had.
I have a question about the data pipeline.
Yeah.
So assuming that you have a data lake and you do the data acquisition, and then you go through the process of data validation, how do you come up with the rules to validate the data is accurate before you pump it into the data prep to a data warehouse?
Yeah,
because
so I mean,
you don't
basic.
want to manually inspect something because too human and error prone.
Totally. Yeah. I mean, so the basic is schema, right? Like, I mean, if there is any kind of schema, right? Data types and things like that. But a lot of testing around, like one of the use cases that I said, right, was that the image captions were coming in a different language. So we automate it, basically you just script it out, right? So basically we had, like I didn't work on this part, but basically what people did is they just write simple, there was an API and they just wrote, a bunch of logic there, including, is the language in English, right? Is the schema is what we expect? Is the image quality, right? So the pixels that we expect out of what? So those kind of rules, which came from data scientists who were doing the researchers actually. So and then they were like, okay, this is what we should be looking at. But there was a constant process of improving, right? So if a new type of problem came, we had to look through and kind of add that automation until so the model accuracy used to tell us a few things, right? So let's say, oh, the accuracy is not good, and we used to inspect, more like the data scientists used to inspect and find out if there are issues, and then we went to the root of it, and then we said, oh, looks like now we have new language other than English. Okay, let's add this validation there. But yeah, like having automation there, it can be any language, honestly, but like acquire the data, run this automation to see if the data is in the valid format, and yeah.
And you also mentioned the data source come from multiple sources, and then
Yes.
and you kind of introduce some biases when you say, oh, this data is works more favorable to us because it behaves the way we expected. So is that, like I said, biases, fairness is not a good thing to introduce through the pipeline?
Oh, I see. I mean, honestly, this fell under more like the data scientist aspect. Like I didn't, but I see what you're saying, as in like, okay, this data is better than the other. But I was more talking about, let's say you aggregated data from various sources, right? So let's say you're getting some customer data, right? But you're also using some other data that goes along with that, not a replacement, right? So you can have an image from one source versus the other and use for the same thing. But I was more talking about, images come from customers, but then let's say zip code data for people come from something else. Or does that make sense? But
Got it. Thank you.
any other questions?
Is it more cheaper to build the AI ML stuff on the cloud versus to have it hosted on-prem?
Yeah, so it's the same thing, but I mean, like it's the same thing as in like it's the same question other software has, but here, yes, GPU is a huge part. I know some companies, I forgot the name, they have this cloud type provider, but more like on demand. I think what we did is, right, we bought some hardware, right, in office. Because we knew we will need that for sure, right? That was more for experimentation and training. But as we grew, right, having the flexibility of provisioning and deprovisioning stuff saved a lot of money. So basically there was, we wrote infrastructure as code. As soon as training button was started, we provisioned the infrastructure, run the training. At the end, we deprovision it. So I would say, honestly, it's a combination, right? Going only cloud and only hardware, because a lot of times if you know you need certain hardware locally, it is good to have, but cloud also gives you the flexibility of, just deprovision the stuff and you're not, you don't have. Plus also the other factor there is, where does the data reside, right, is a big factor. If it resides with customer or with you, doing that data transfer might be costly. So having that closer, the machines closer, right, infrastructure closer is easier. So there is no silver bullet, but I would say is things like infrastructure as code, automation for provisioning and deprovisioning, and even on premises, having automation to free up the resources for other people is important. At one point, we had people just logging into this GPU machine and just doing pip installs, right, all across, right? Like, oh, I need this library. Oh, someone else does that. And then that was a mess. And then we looked at automating that, right? So that you can install stuff, but then that you can easily wipe away, right? So
you also mentioned you have part of the hardware hosted in-house, and then you also say some of them overflow to the cloud. But the cloud solution have other what do you call that, services, like you said SageMaker, for example. Does that mean that you build your application to always use the API that the cloud uses, or to be complement to it, or something like that?
Yeah, so in our case, we were not using SageMaker. So if you are cloud only, you are actually using the managed solution, then I don't think doing it on-prem, like, in-premises stuff might, like, unless the data, right? Again, like there are factors like where is data, how large is the data. If you're using SageMaker, maybe doing some initial processing and then sending the data is cheaper and less time consuming, right? In our case, we were not using the managed option, but I would imagine if that's the case, then I would look at, okay, if I have to transfer terabytes of data every day, maybe having some initial processing, and only sending, the process data is cheaper and less time consuming.
I have a question. How do you do regression testing? Because the way I do regression testing in the non-ML world is I take the data set and that demonstrates the bug and save a copy, and I always run the software on that data set and make sure that the bug doesn't reappear. How do I do that when my data set is terabytes big and I can't do that for every bug?
Right. And this is making that reproducible is a big challenge. Some of the things you can do, right, like is data versioning and your artifact versioning that we talked about. But for like two aspects. One is if you want to do regression on your training aspect, right? I think you have to get all the various components together to do it. And it is much difficult because it's more time consuming. If you want to do testing against live data, right, more like prediction, which is much faster. But yeah, like it is a challenge. I don't think I have a good answer. All you can do is make sure that you have the various ingredients that go into a training or a prediction process properly versioned and tracked, right? So if you use things like Kubeflow has it, all the other frameworks have it, but you can track those experiments and say like, this is the output I got with all of these ingredients. How do I reproduce? So if you want to reproduce, you go back and take that ingredients, try to do regression. But again, it can take days, so it's not easy to be like, oh, I'm going to run this regression again. It might take 3 or 4 days. So I don't think I have the right answer for this, but I feel like some of these practices, if you do, it makes life easier, basically.
Sure. Thanks. I think the data versioning thing, I hadn't thought of that. That should help a lot.
Yeah, there is actually, there are tools for, so DVC is like a data versioning tool, like GitHub, but it's specific for data because data size and other things. So there are certain tools to track that, because if you try to push that to GitHub or some database, like it's massive. So there are certain tools available to track those things.
Mm-hmm.
And then, like again, like doing the whole thing. So figure out what's the right, that's why like this role that's only focused on data helps in creating that testing data, which is probably less in size, right? So you don't have to like run this every time.
Sure. Awesome.
If you have a large data set, do you use to store them as files or to a relational database or non-relational database like NoSQL? What would be the way of doing it?
Yeah, I haven't used it, but DVC, I'm sure someone in this call has used it. But if you look at DVC, that's a specific tool for storing data and versioning it. I don't know if anyone on the call has used it or want to talk about it, but that is one thing that I've seen people use it. But relational, I like, again, I don't think relational might be a good choice here, especially if it's massive data set, but yeah. Also, there are tools of, yeah.
Oh, I was going to say we should wrap it up, but maybe this is a good point to end on.
Yep. Yeah, I mean, feel free, my Twitter handle and my email is also on my website. Feel free to tweet or DM me or email me if you have further questions.
Great.
So yeah, I hope it was useful. And yeah, let me know anything else, contact me for anything else.
Okay, well, why don't we all unmute and give Adarsh another round of applause. Okay, and we'll figure out how to do that better next time.